So with questions like 5.7, right? Let me just delete this. The idea is to just what is the idea now? Let me try and put this in a simple way as possible. So whatever we're gonna do now, you will be able to. I'll just show you which other playlist you can have a look at for you to also better work with these kinds of questions. So there's a playlist, I think on the main channel. I think it's called Inequalities Grade 12, where it works specifically on these kinds of questions that we're looking at now, like specifically, like 100%. For example, if I go to playlist, you just want to look for Inequalities Grade 12, because the kinds of questions that you'll go through here are exactly like the ones that we're looking at right now. So firstly, the idea with something like this is you want to just recognize that you have an expression here, and this expression is two things contribute to what number this is going to be. Because if you look at this, they're saying, given that p of x is this, so where is f of x now? We at least need to get f of x now. So okay, yeah. So f of x according to 5.3, f of x is technically a is a 2, b is a 3, and then c is a negative 10. So all this being said, we already know that here they said, given that p of x is this, so automatically we want to find out what is p of x before even worrying about this question. P of x is going to be the equation that we have there plus 1. So it's going to be 2x squared plus 3x, negative 10 plus 1, that's a negative 9. And then we now see, okay, this is what p of x is, right? So they're saying here, determine for which values of x, determine the values of x for which this side is smaller than 0. So in terms of an interpretation, they are literally saying you have two things on the left here. You have an x value being multiplied by a y value. You see, they're asking, where is this times this going to give you a number that is smaller than 0? So before you even worry about this specific question, the idea is already that if any two things are going to be multiplied by each other, for you to get something smaller than 0, it means that one of them has to be a plus while the other one is a negative. Or the first one has to be a minus while the other one is a plus. You see, these are the only two scenarios where your number on the left is smaller than 0. You see, for your number on the left to be smaller than 0, one of them has to be a negative. You see, for your number on the left to be smaller than 0, one of them has to be smaller than a 0. You see, one of them has to be a negative, because for you to get something smaller than 0, you'll always have to say a positive number times a negative one, or a negative number times a positive one. Does that make sense?
Yes, yes.
Yeah. So that's the first thing we want to keep in mind. So because we already know that, you see, the other thing is, now with questions like these, right, you always usually want to make use of your picture. So the picture we were given here, this is like f of x. So let me just try and see here if we can just map out f of x. So this is f of x. Ish. Try and make it a bit better. If it doesn't work, it's fine. So this is what f of x is, right?
Mm.
So the idea with this f of x, let me just do freehand. The idea with this f of x is this f of x was moved 1 unit upwards. So let's just try and see what we can do here. So this is f of x. So they took f of x, they moved it 1 unit upwards. So meaning f of x is now looking like following. So f of x now, this thing now. This f of x now, instead of it being down here, it's gonna go one up. So it's gonna be somewhere there. Fine. Once f of x was moved one up, now they are asking, right, where are you going to get this left expression being a number that is smaller than 0? So the easiest way to answer this question is you want to look for cases where your y values are a negative while your x values are a positive. And then in that same image, you also want to look for cases where your y values are a positive while your x values are a negative. So saying it in words, it sounds a bit weird or a bit off. But then this is all we need to do. If you're looking at this picture, right, I mean, like the way it looks, you already know that everything up here, these are positive y values. You see, this is where p of x is going to be a positive. Do you see that? Connection?
Yes, I see it. Sorry, my mic was off. I was busy saying I
Oh,
see it. Yeah.
no problem. Yeah, so this
Yeah.
is the only parts where the graph of p of x is a positive, and then this also has positive y values. Now, if you look under it, obviously that's the parts where it is having negative y values. Fine. Now we have dealt with p. We have dealt with where p of x has positive numbers, and we have dealt with where it has negative numbers. Now let's do the same for x. If you're looking at x, we just need to find out where are the x values are positive. The x values are positive over here. And then where are the x values are negative? The x values are a negative going to the left. So going to the left, let me just try and find, let me just maybe use like a red. Going to the left, we know that that's where our x values are a negative, you see.
Yes.
So just by looking at this, you can even maybe be doing this on your own in like a exam. It doesn't matter as long as it will help you think. So now without maybe overthinking it, right? Let's see here. This is where we have negative x values. And then this is where we have positive x values on the right there. So the exact same way we're doing it now, you want to be comfortable to maybe do something like that in your exam to show you that you can be as free as possible. So now you can see here, we just want where we have a mixture of the two happening at the same time. We want cases where we have negative x values while having positive y values, or we want to have negative y values while having positive x values. So if you look at your picture, you can already see that here, the green part here, we have negative x values, and that same place we also have positive x values. Let me repeat. If you look at the green part here until here, and if you look at the orange from here until there, do you see that that's a spot where we have positive x values and we also have negative y values?
Yes.
Yeah. So now in
Yeah.
terms of giving an answer, your answer here, according to your question, you have to give the x values where that is happening. So we can see that it's happening specifically. I need a color that's gonna pop now. Which color can I use? Yeah, I used all of them. Let me see, maybe this blue. So if you look at it nicely, the part where you have negative y values and positive x values, it's from this x value over here until this x value over there, which is the x value of, you see, I don't know if the question gave us that or we were asked for that at some point in time.
They said it's
But
3B.
B is 3.
Yeah.
Oh, you worked it out.
No, it's on the third question. It was worked out, but they gave you answers as well.
Oh, wait. Oh, yeah, no. This one is the small b over here. The
Oh,
small b over
okay.
there. Yeah. So we're talking about this x-intercept over there. But let me see. Yeah, so obviously to get this x-intercept, we would have just solved for x here. So we can quickly just solve for x and see which two x-intercepts we get. Let's see. minus b plus minus b squared minus 4ac 2a. And then here, you're going to have bracket fraction negative 3 plus square root of 3 squared minus 4 bracket 2 close bracket negative 10. And then you have 2 times 2. Well, it's going to give us 1 point some. Oh, no. This is the equation of f. It's supposed to be using the equation of p. So this would be a
9.
negative. Yeah, because only the y value changed. So let's see. Negative 9. It's giving us 3 over 2. That's the x value, the positive one, which is the only one we need right now. So the x value here is a positive 3 over 2. And then the x value here is a 1. So obviously part of our answer, we're going to have to say our x values are between 0 and positive 3 over 2. So our answer, let's see, that's for 5.7. So for 5.7, we're going to have to say x is an element of 0 until 3 over 2. So the reason, let's just see if we're going to use a square bracket or, yeah, we're going to use a square bracket. I mean, a round bracket. The reason we're using a round bracket is because we're trying to say from 0 until 3 over 2. The reason we're using round brackets is because specifically at 0, we know that the x values are 0. So 0 times something is not smaller than 0. And then here also, the reason why we're using a round bracket is because specifically here, the y value is a 0. So 0 times something is not smaller than 0. So we have to say x is between 0 and this, and we have round brackets. That's the first part of our answer, where we are getting positive x values and we are still seeing negative y values. Now we need the opposite. We want where we are seeing negative x values together with positive y values. You see, because you see here, these are representing positive y values. And we are seeing that specifically from this x value over here going to all the x values on the left, you see. So our answer here will have to say x is an element of negative infinity up until this x value, of which that x value, we can get it here. Pardon?
It's 3. I calculated it, negative 3.
Oh, perfect. So it's negative 3 there. So that's the other x-intercept. So here we can see from negative infinity until negative 3. And then that'll be that.
Okay. Now I see it. I just think the way they explained it, it just confused me. So I just, yeah.
No, I hear you. So you can see how messy it is right now, and you can be comfortable to do what we have done, do color stuff, circling, seeing what is positive, seeing what is negative, because the exact same way we're explaining it now is the exact same way a person would want to work it out. You don't want to keep things in your head and just try and figure it out in there. You want to see it nicely. And this is something that you can check or you can do for other kinds of questions. And as said, with this playlist here, it will also give you different examples that you can use to help you work out questions like these. Cool.
No, I get you. I'll go through it and check. Yeah. Thank you